Hi Year 10, welcome to Chemistry 101. Bit of a background from last year so that we can go forward with this year's work. We're going to start looking at the atom. So the atom that you can see is the lithium atom, and it's a beautiful thing. It's nice and balanced. It's got a nucleus in the middle and it's got electrons spinning around the outside. Okay, in the nucleus we can see we've got protons and neutrons. The difference between them is that the protons all have a positive charge and the neutrons are neutral. You also see that there are 3 protons and they balance out the 3 tiny electrons whizzing around the outside. And remember, there's heaps and heaps of space in here. This is quite a big nucleus. These guys are really tiny, so this is a bit deceptive. Did you know that if we got rid of all the spaces in our atoms, that we would be the size of a flea, but we would still weigh the same amount? Okay, so our atom at rest, it's balanced, it's got the tiny electrons and neutrons, and you just want you to notice that the number of protons and the number of electrons are the same. So any of the elements that you see on the periodic table, when you look at their atomic number, so lithium atom, its atomic number is 3, we can know that it has 3 protons and 3 electrons. If it's an atomic number of 6, we would know that that atom, which I think is carbon, has 6 electrons and 6 protons. Okay, so what makes them stable or reactive? How do we know which ones are going to react with something quickly or some that aren't? Keeping on with our lithium atom, we can see that the protons are positive, neutrons are neutral, and electrons are negative. Atoms with the same number of electrons and protons are neutral, and that makes sense because each pair, like a plus and a minus, balance each other out, plus and minus balance each other out, and those two balance each other out. So overall, we do not have a charge. We notice that the electrons are actually arranged in a certain way. We call these things shells or energy shells. They're not really, but it's kind of a space that we can imagine they all live in. The first one only fits 2 electrons in it. The second one is a lot bigger. It can fit 8 electrons in total. If there's an extra electron, so say that we've got an element that has 10 electrons in it, it would have 2 electrons here and 8 electrons there. If it has 11 electrons, that 11th one would start a new energy shell. Okay, so what makes an atom stable or active still? The atoms really like to have their outer shells full. So if you have a look at these guys, we've got helium, neon and argon. Coincidentally, these are the elements that are on the very end of our periodic table, and they're incredibly stable. There is nowhere that they can fit another electron in, and they don't want to give any others away. The other thing that we can look at here is this thing called electron configuration. That tells us not only how many electrons an element has, it also tells us how they're arranged. So helium has an electron configuration of 2, because it's only got 2 electrons in its first shell. Neon, we say that its electron configuration is 2, 8. It has 2 electrons in its first shell, 8 electrons in its second shell, and its atomic number is 10. So you add 2 plus 8 together, and it gives you what the number is. Argon, you can see it's got 3 full shells, so its electronic configuration is 2, 8, 8. If we look at some other ones, take sulfur for instance. Its atomic number is 16. Its electron configuration is 2, 8, so it's filled up 2 shells, and then the last 6 are in that third shell. Elements whose atoms only have 1 electron in their outer shell are said to be highly reactive. They really want to get rid of this electron. They just want to have this nice outer shell here. One of these is sodium. Its atomic number is 11, and its electron configuration is 2, 8, and then you've got that 1 there, so that tells us it's going to explode, it's going to burst into flame, it's going to do all sorts of stuff that it likes to do. Other elements that are really reactive are ones that need 1 more electron in their outer shell. So chlorine's another one of these. Its atomic number is 17, electron configuration is 2, 8, and you can see its last one is 7. So it needs 1 more to make its shell nice and complete. Can you think of an element that would be able to provide that 1 extra electron quite easily? I hope you can, because it is sodium. So this is what happens when we make the salt. This is why we can get a poisonous sodium and a very poisonous gas is chlorine to make something really harmless. If you look at this little GIF here, they're joining together, we can see that that one electron jumps over to the chlorine and those two get attracted together and make sodium chloride, a really stable compound. Okay, what we're going to do next is we're going to get you guys to try and write a few electron configurations, and then we'll go on to why we get this positive and negative happening and what that kind of bonding is called. Thanks, Year 10.